Solve the following homogeneous differential equation. We have dy dx is x plus y over 2x. So let y be equal to xz. That means dy dx is, using the chain rule, z times dx dx, which is just 1, so that's z, plus x times dz dy. So we're just using the product rule, dz dx, just using the product rule there. And so what we end up with is z plus x dz dx, replacing the dy dx, and then y equals xz would give us x plus xz over 2x. And that gives us z plus x dz dx is equal to 1 plus z over 2. And so x dz dx would be equal to a half plus z over 2, take away z, that being the z from here going on to the other side. And so x dz dx would be equal to 1 minus z over 2. So we can now separate and integrate, and we get the integral of 1 over 1 minus z dz would be equal to a half of the integral of 1 over x dx. So we get ln 1 minus z over minus 1, don't forget reverse chain, is equal to a half ln, and we're going to write mod x. We could have plus a constant, but if I make that constant into a half ln c, I can then use a log law to bring that in here. And so we get ln 1 minus z to the negative 1, should still be a modulus really, but let's not worry about that, is equal to ln cx to the half. And so ln 1 over 1 take z is equal to ln root cx. Now ln of this equals ln of that, so 1 over 1 minus z would be equal to 1 over root, would just be equal to root cx. And then that gives me that 1 minus z is equal to 1 over root cx. And therefore z is equal to 1 take away 1 over root cx. Okay, don't forget though that we let y be equal to xz, which means that z is equal to y on x. So y on x is equal to 1 take away 1 over root cx. Therefore, y is equal to x minus x over root cx. And then we could write that as y equals x take away. So root cx is root c root x. And if we've got an x on top there, x divided by root x ends up being root x. And we can just say 1 over root c is another constant, such as a. So we get y is equal to x take away a root x.